Thank you, everyone, for coming today. Well, my name is Carlos. I'm here with my colleague Kartik. Well, myself, I'm from Mexico City. I'm part of the SD-WAN tag team. So thank you for coming all today. Here with me is my colleague Kartik.
Yeah, hi. My name is Kartik. I'm a technical consulting engineer from Richardson Tag Team. I have 7 years experience as a SD-WAN network engineer. I am a Cisco certified SD-WAN professional. Thanks, Carlos.
Thank you, Kartik. Well, both are the team leads of our teams. So thank you all for coming here today. And today, as you can see, we're going to talk about the troubleshooting of the BFD sessions. Very, very useful for the SD-WAN deployments. So what's our agenda for today? We have first our introduction, why we need BFD, what's used for, how we build the BFD sessions, why OMP protocol, overlay management protocol, is important for us, and we're coming back to the control plane verification. We want to cover the worst case scenario. You need to start from scratch to start troubleshooting. So we're going to see in detail all the steps there. Then we're going to review the two most common scenarios we have in TAC. So, and also the packet trace. We have a couple of features that we use daily, so we can actually troubleshoot these problems. So, and we want to show you how we do that and some examples. Okay? And at the end, we have the Q&A. We have a bunch of slides. Please save all your questions, comments to the end. If we were not able to cover that, please, our booth is next here. So we will be happy to have you there. Okay? So first, our introduction. So why BFD is important, or why is BFD, or why we use BFD? So basically, as you can see here, BFD helps us to monitor reachability between two remote sites. We need to see if the tunnel is up or down. That's it. Why this is important? We are going to review that. Also very important, we are not only going to monitor if everything is up or down, we also need to store information. So we can have two tunnels, two BFD stations between two different sites. So what means that? That we can, if we store the information, we can know which is the best path. And with a policy, we can actually change the way we're forwarding the traffic. So that's why it's very, very important. Also, if we have the loss, if we're able to monitor the loss, of course we're going to monitor the latency and the jitter, which is our best path in the end. That's what we use this for. Also, it's important to know that you cannot disable this protocol, but you can customize how often you are sending them, how much time you are going to wait until you tear down the session. And also, you can monitor how much data you are going to store. So how much time you will take before switching over the traffic. And one thing I would like to add, also the IPsec MTU. We want to ensure that we're using the maximum MTU between two routers, so this protocol is going to help you to actually determine that. Now, how we establish the BFD sessions. First, we need to go through the OMP protocol, the overlay management protocol. This protocol helps us to build everything in SD-WAN. So what we build with OMP, the virtual fabric. Why this is important? It's basically how we route everything through the overlay. We can actually modify the way we are forwarding the traffic, a hub and spoke topology, a full mesh, which tunnels we're going to use. That's why we need the virtual IP fabric. That's our logical topology. Also, we have our layer 3 segmentation. You want to separate the traffic from your network from your guests. This can easily be done with this. Also, you have IPsec tunnels between two remote sites. This protocol helps you to build that just as easy. We can have some policies for the routing to modify the traffic flow. OMP helps us do that very, very easily. And of course, we need to confirm if we have reachability between two sites. So BFD is going to help us to monitor that very, very constantly. Now, how we achieve this? We have OMP. We're going to see this in detail with the show commands, but basically what's the idea with OMP? So we have our two routers, two different sites. So we have our TLOC, our transport locator, the interface that is in charge of creating the BFD tunnels and the control connections. So in this particular case, you have two ISPs. It means you have two TLOCs. And these ones are the ones that are going to create the control connections, in this particular case to the controllers, but the vSmart in particular, and the IPsec tunnels that we have. So that's what we need to use. So as soon as we have the IPsec tunnel, we have the BFD sessions that goes inside the tunnel. We're going to see that in detail, okay? So how we verify the control plane? Let's imagine that you are the guy who supports the whole network of your company. Worst case scenario, someone called you in the morning, site is isolated. I don't know what's happening, just everything is down. Okay, so that's the worst case scenario. How are the steps to actually see what we need to check, okay? First thing, we need to check the transport locators. The interface that it's meant to build control connections, IPsec tunnel. Things that are very, very important from here, the physical interface. The physical interface has a color. And of course, what's the state of that color? It's up or down, basically. So if it's up, that should be able to build control connection and BFD sessions. Things are very important again. The interface, it's binded to the color, and what's the status. Also, you have the vSmart BS/VM, how many vSmarts, and who is connecting to the vManage. So that's why we can check this. Now, these are the control connections. It's the highway, the road to the controllers. We only know at this point that we have connectivity. Then let's move to the control connections. You can see the control connections at this point. Again, the road, the highway, the connectivity between them. We can see that this particular TLOC, in this case, this internet, is able to actually build the control connections. You can see on your left, which is it's a controller, which is the color, and most important, the uptime. Here you can see the status of your network. It's been up for 24 hours. It's not likely that you'll have a reachability issue. So these parameters are very, very important. But I want to be very, I want to focus on this. This is only the highway. This is only the connectivity. We can move forward and see the TLOC exchange. Here at this point, we know the control connections, it's already up, but we can confirm that it's been exchanged. In this case, TLOCs. Now, in this output, if you can see here, you have 0, 0. What means that TLOC belongs to the router. So this one, the two at the bottom, belongs to this guy. So we know there are up, and it's exchanging that, it's sending that information to the vSmart. Now, the tree at the top, it's the information we are receiving from the vSmart. So at this point, we have confirmed that we have connectivity toward the vSmart, and we are actually exchanging information. Now, with this information, or both routers are going to use it to actually build the BFD session. And it's actually this. Now, here we can see similar scenarios. The remote system IP that we are using, the one we use to connect, the colors we are using to establish the session, the local color, the remote color, and the two most important parts, the IP addresses that we have. Please notice these two IP addresses are going to be very, very useful for the next slide. Things that are important: source and destination, and also the uptime. So maybe we don't have reachability, but if we see that the uptime, it's been 48 hours, maybe 2 weeks, okay, so the BFD session is stable. So we may suspect a routing issue. And the last one, the last column, the transitions. The transition basically tells us if the IPsec, if the BFD session is bouncing. Okay, so it's bouncing, it means that we may have a reachability issue, and that's something we need to address. So if you can see this, the topology here, we already confirmed that the TLOC is up. The TLOC is connecting towards the control connections, in particular the vSmart. It's exchanging information. It's taking that information to build the BFD, the IPsec tunnel. And the BFD packet or the BFD session goes inside the IPsec tunnel. So the IPsec is encrypted. So how are we going to make sure that we're exchanging packets? That's our next slide. Remember the IP addresses I mentioned. This was a regular packet capture in the physical interface, that the one that's binding with the TLOC. And here you can see that I'm just filtering those two IP addresses. Those two IP addresses, here you only see traffic going back and forth between these two devices. But what's important of this regular packet capture, this differentiated service code point, the DSCP value of the packets. Here, if you notice the column, you will see that you have your DSCP CS6 or DSCP 48. What's important of that particular value is that the one that we use for the BFD packets. So if we do a packet capture, if we see a ton of different DSCP values, we are able to find the CS6, the DSCP 48, to make sure that in particular is our BFD session. And we can use the packet capture, the packet number, the time, to actually see if we are sending and receiving the right information. We know how often we need to send the BFD packet and how often we need to receive that. So this can give us an idea that if we are dropping BFD packets in the middle of the network. Okay? Now, at this point, again to the drawing, we know that everything is working at this point. We have the TLOC is up, communication towards the controllers is exchanging information, it's setting up the communication between sites. Now, what's missing? The regular IPv4 routes, the routes that we have in our LAN in different sites to actually exchange the packets. Now, and that's what we're going to see with this command. We took this from a router, so the router is connected to the vSmart. What's the status? The status is up. The uptime is 17 minutes, and here is the most important part. We are exchanging routes, information. How many routes we received, how many we installed, and how many we are sending. So that's why we can actually see that we are exchanging information to all the environment. So that's how we troubleshoot since the beginning. And up to this point, we should be able to see that we have reachability between two different sites. Okay? Now, we're going to see the troubleshooting scenarios. We're going to use this information to actually see real-life problems. So my colleague Kartik, please.
Thanks, Carlos, for covering introduction on BFD and control plane verification and overlay management. Now we're going to troubleshoot two of the most common BFD issues. Scenario 1. So here we have a issue with one of the transport link where the BFD session is down. In this topology, we have hub and spoke topology. Both the transport links are up, and both the routers were sending the traffic to each other. But all of the sudden, customer experiencing BFD session down on the MPLS link, and there is no data traffic forwarded between the routers. And similar troubleshooting steps are followed for full mesh topology between branch to branch. First, we're going to log into the spoke CLI, and next we're going to log into the hub side and see what's happening there. So first, the two transport links and the control connections are up on the spoke side. To check the BFD state is up or down to the hub side, we need to run show SD-WAN BFD session. From this output, we can clearly see the state is down. Now, furthermore, we need to check if the traffic is going out of the spoke to the hub. To check that, we need to run show SD-WAN tunnel statistics to the destination, which is hub. From this output, we can clearly see that transmit packets we can see the transmit packets, and the receive packets are 0. We need to run this command couple of times to see if the counters are getting incremented or not. Furthermore, we can run the ping and traceroute command to the destination and see if there is any issue between the spoke to the hub. So the fiat trace feature is one of the useful tool in the iOS XE router. From using this tool, we can clearly know if the packets are leaving out of the box. To run this feature, we need to run the debug platform command to the destination, to the hub. So from these, to check if the packets are leaving out of the box, we need to run show platform packet trace summary. Here we can see the state is forwarded. To check in detail of each packet, we need to run the show platform packet trace packet decode, from which interface it is leaving, and the state, what state it is in the drop or it's forwarded. This tool is very useful if we see any drop packets here that could be related to any ACL or any firewall. We can clearly see here. From this, we can know that the spoke is sending the packets. Now we're going to log into the hub side and see what's happening there. On the hub also, both the transport links are up and the control connections are stable. To check the BFD session to the spoke, we need to run show SD-WAN BFD session on the hub side too. From this output, we can clearly see the state is down, and we need to confirm if the hub is sending the traffic or like or it's not, if it's blocking there. From the hub also, we can see the traffic is moving out and it's not receiving anything. We need to run the same command couple of times to see if the counters are getting incremented. And we also need to run the ping and the traceroute command to see if there is any issue between the path. On the hub also, we need to run the fiat trace feature, the debug command to the spoke, to check if the packets are leaving out of the box. From this output here on the packet trace summary, we can clearly see the packets are forwarded. To check in detail of each packet, we need to run the decode command to see which interface it is leaving and what is the state of it. From these outputs, we can clearly see that we can conclude that both the hub and spoke, they are sending the traffic, but they're not receiving on their ends. This could, there could be an issue like issue between the path. It could be related to the firewall or any network devices related to the L2 device or L3 device. It's always recommended to have all the network administrators who are handling the firewall team and the layer 2 or layer 3 device on the call, so that we can resolve this issue as early as possible. So next, troubleshooting scenario 2. This is the most common tag case. We see control connections and the BFD flapping all together at once. So in this scenario, we have hub and spoke topology, where and two transport link, biz internet and MPLS. Biz internet is keep on flapping, and customer has opened a tag case to resolve this as early as possible to avoid the downtime. So similar troubleshooting steps are followed on the full mesh topology between branch to branch. First, we're gonna go to the vManage GUI to check if we see any events there. So to check the events, we need to log into the vManage GUI, monitor network events. From this graph, we can clearly see how frequent the data path and control plane are flapping. If we click one of the event, we can clearly see what is the reason, what is the flap reason. And as we clearly see, it is due to the timeout, which means like there are packets which are getting missed to the hub. Next, we're gonna log into the spoke. We're gonna first check the interfaces, WAN interface list. From this output, we can clearly see that it doesn't have any control connections to the vSmart. On the biz internet, on the MPLS, you can see it has control connections to the vSmart and for the vManage. To check the control connections are up or down, or it's trying to connect, we need to run show SD-WAN control connections. From this output, we can clearly see that the device is trying to form the control connections on the busy internet. Now we need to run the show SD-WAN control connections history to see what exactly the error is, local error is. From this output, we can clearly see it is a deconf and the timeout error. What exactly that means is the packets are missing when it's trying to form the control connections. To check the BFD session to the hub, we need to run show SD-WAN BFD session. Here, in this output, we can clearly see both the BFD sessions are down to on the busy internet. So to check if the packets are sent or received on a particular tunnel, we need to run the show SD-WAN tunnel statistics BFD. From this output, we can clearly see the packets, the transmit packets and the receive packets both as 0. That means there is no traffic that is being sent to the hub. So if we need to also run the show platform hardware QFP active future. BFD data path SD-WAN summary. In this output also we can see the state is down on the busy internet. So after a while, what happens is as there is a port hop enabled on the device, so it tried to move to the different port and try to connect to form the control connections. As you clearly see here, it moved to the 123.8.6. But on the tunnel statistics, it's still on the old port. It did not sync. Once the issue gets resolved and your control connections are up with the vSmart, and the new port will be updated on the tunnel statistics. Yeah. And any Q&A answers. And please, if you like this session, please do the review.
Guys, any questions?
How did you sync it? I mean, you just said you noticed the difference in ports, but how did you sync it?
It could be a ISP issue or like we need to check.
Local router, correct?
Sorry?
It's using the port from local router.
Local router, yeah. Yes.
So how did you switch the port?
It is a port hop.
By default, you have a feature called port
hopping.
So when port hopping, it tries to establish the session. If for any reason you cannot establish the session, you say, okay, I'm going to use a different port and start again.
Is that a command you run?
By default, it is.
No, it is automatic. We have like 5 to 6 ports.
Okay.
It moves after some time. It tries to form on a different port because there could be a firewall in between, and customer has configured only few ports open. And what happens is like when it goes to the new port, right, it will try to to form the control connection.
Well, just to sync with everybody, what was the question? Okay, so how we fix the problem? In this particular thing, you have a feature called port hop.
Port hop.
It's like a command, but it's a process that is constantly doing. So you can disable port hopping. In this case, you have port hopping enabled. So the router, it tries to establish the session with one particular...
there's a command to disable it.
So you try to establish the session. If you are not able to, it does a port hop. It tries with a different port. And the router keeps doing that. So at some point, we expect that it's fixed because this is a problem like something in the middle is dropping packets. So as soon as it is able to establish the session, it will remain stable.
What is the command?
Okay. Yeah, the command. Yep. In the system block, you have port hop enabled or port hop true.
Yeah. In show SD-WAN control local properties, you can see the port hop is enabled or not. But we need to run the request platform software. There's a SD-WAN where you get an option to disable the port hop.
You can also trigger a port hop at will. I mean, you can manually go request and do a port hopping. Yeah, but by default, you can enable that. Yeah, the router will try to do it automatically.
Yes, sir. So you had a question? That is for the port hop to the... But we want to disable. If you want to disable, right, we need to go inside the box and we need to put that as a disable port hop. Yeah, disable port off. So what you're saying is the color. You are saying on a particular color, you want to try on a different port. The one you were saying, yeah. Yeah, that's what, yeah. Default timer, I think it's 2 to 3 minutes. After some time, it's gonna try it, yeah.
Yeah, and if you trigger that manually, like request platform software SD1 port hub, you need to wait. I mean, if you run that command, you need to wait like 20 minutes so you can actually able to run it again.
So all of these are underlay problems, right?
Correct.
Yeah.
So how do you have a good way of troubleshooting overlay problems? Say, for instance, I know one of my edges is announcing a particular prefix. I know the vSmart sees it, but hell, my other router doesn't see it. How would you troubleshoot?
Okay. May I? Okay, the question is, we cover underlay issues. So he is asking me about what's happening if I don't see the route. Okay? So not in the overlay, but in the underlay. Oh, sorry, in the overlay. So let me go to the. Okay. For instance, here, this one. Okay. So basically, we were troubleshooting scenarios that the packet from here is not reaching this guy.
Yeah.
So that's what we cover up today. The question is, I'm in VPN 1. Here I have a subnet, and this router is not able to reach that particular subnet. Okay, so how we troubleshoot that? Basically, here we have the VPN, and the VPN needs to make sure that we are sending that into the vSmart. The vSmart needs to send it to the other peer. So we need to do a command that is called show SD1 OMP routes. We can do show OMP routes here in the vSmart to actually see that we are receiving the route. The vSmart is receiving the route. Then we move to the other router. We again show SD1 OMP routes, and let's see if we receive it.
Okay, so now suppose you don't receive the route from the vSmart and you don't know why. How do you get to that?
You need to check the policy. It's likely that the policy is filtering that prefix.
Is there any way to see which policy is filtering it, or you just need to go into your policy?
So you can run the fiat whatever the fiat trace feature I have said, right? The debug commands. The packet cap, yeah, here, right? When you run this debug command, so in this output, we're gonna get the complete in detailed, like which feature is blocking. So on the future, for example, you have created a policy name. You're gonna get a policy name here, and the action is drop. You're gonna see that by using these commands.
Packet trace.
Yeah.
Okay.
Yeah.
Maybe we don't have time for more questions here. Our booth is next to this session.
Year.
Everybody's invited, so please, if you want. And thank you all for coming today.
Thank you.
Yeah, but please, if you want to go.